How often do you think about your heart health? Are you aware of the risks of cardiovascular disease? Well, let's dive into the heart of the matter. Cardiovascular diseases, encompassing coronary heart disease and stroke, claim the top spot as the leading cause of death in the United States. Particularly at risk are blacks and Hispanics in underserved communities. It's a sobering reality, isn't it? But there's good news. Cardiovascular disease is largely preventable. Stay tuned to learn how you can keep your heart beating strong. Heart Smarts, a health program, is here to empower you to live a heart-healthy lifestyle. This program is not just about information, but about transformation. It offers a comprehensive approach to help you understand and achieve heart health. Heart Smarts is committed to reducing the incidence of cardiovascular disease, the leading cause of death in the United States. The program focuses on underserved communities where the risk of heart disease and stroke is greatest. Through education and empowerment, Heart Smarts aims to turn the tide on these statistics. It's a call to action, a call to change, a call to live healthier, longer lives. Heart Smarts is about arming you with the knowledge and tools you need to make heart-smart choices every day. It's about the power of prevention and the promise of a healthier future. Remember, Heart Smarts is not just a program, it's a life-changing journey. It's about taking control of your health, one heartbeat at a time. But don't just take our word for it. Listen to these stories from people who have benefited from Heart Smarts. Imagine being told you're at risk for heart disease, a leading cause of death in the United States. Now picture having the knowledge and tools to combat that risk head-on. For people like Maria, a single mother from an underserved community, Heart Smarts was a beacon of hope. The program informed decisions about her heart health, ultimately reducing her risk of cardiovascular diseases. And then there's John, a middle-aged man who was once a prisoner of his poor lifestyle choices. For him, Heart Smarts was not just a program, but a lifesaver. It opened his eyes to the risks he was taking and gave him the push he needed to commit to a healthier lifestyle. These are not just testimonials, they are life-changing stories. Stories of empowerment, resilience, and triumph over heart disease. These are real stories from real people who have seen the impact of Heart Smarts in their lives. Are you ready to be the next success story? Your heart health is in your hands, and with Heart Smarts, you have the power to make a difference. It's time to take that first step towards a healthier lifestyle, a step that could redefine your future. Heart Smarts is not just an ally, it's a beacon, guiding you to make informed decisions for your heart health. So why wait? The path to a healthier heart is just a click away. You'll find the link to Heart Smarts right down in the description below. Start your journey towards a healthier heart today with Heart Smarts.
Ladies and gentlemen, today, I stand before you to delve into the fascinating world of concrete, a material that has shaped civilizations, enabled architectural marvels, and continues to be the bedrock of modern infrastructure. As engineers and physicists, we are intimately familiar with the profound impact that concrete has had on our societies, and it is imperative that we understand its intricacies and potential to pave the way for a sustainable future. Throughout history, concrete has played a pivotal role in the development of human civilizations, from the ancient Romans' use of volcanic ash-based concrete in the construction of aqueducts and colosseums to the modern era's utilization of high-performance concrete in skyscrapers and transportation networks. The evolution of concrete reflects the ingenuity and progress of engineering and physics. Understanding the material properties of concrete, such as compressive strength, elasticity, and thermal conductivity, has enabled engineers to push the boundaries of architectural design and structural innovation. At its core, concrete is a complex composite material governed by the principles of physics. The interactions between cement particles, aggregates, and water give rise to a heterogeneous microstructure that influences the material's mechanical properties and durability. Through rigorous experimentation and theoretical modeling, physicists have elucidated the underlying mechanisms governing the behavior of concrete at various length scales, from the atomic arrangements within cement hydrates to the macroscopic deformation of concrete structures under load. In the realm of engineering, advancements in concrete technology have led to the development of specialized mix designs tailored to specific applications and environmental conditions. From self-consolidating concrete for intricate architectural forms to ultra-high-performance concrete for seismic-resistant structures, engineers leverage their understanding of material science and fluid mechanics to optimize the performance and workability of concrete. Moreover, the integration of reinforcement techniques, such as steel rebar and fiber reinforcement, enhances the structural integrity and resilience of concrete elements, allowing for the construction of robust and durable infrastructure. As we confront the challenges of climate change and resource depletion, the quest for sustainable concrete solutions has become increasingly urgent. Engineers and physicists are exploring alternative binders, such as fly ash, slag, and calcined clays, to reduce the carbon footprint of concrete production. Additionally, innovative approaches, such as carbon capture and utilization, hold promise for mitigating the environmental impact of cement manufacturing. By embracing interdisciplinary collaboration and embracing holistic life cycle assessments, we can chart a path towards more sustainable concrete practices and foster a greener built environment for future generations. Concrete, in its essence, is a composite material whose properties are deeply rooted in both engineering principles and fundamental physics. The interplay between cement hydration and aggregate distribution, for instance, governs the material's strength and durability, drawing upon concepts of particle packing and intermolecular forces. Moreover, the evolution of concrete as a building material is intertwined with the history of civilization itself. Ancient civilizations, such as the Romans, utilized concrete in the construction of aqueducts, amphitheaters, and monumental structures, leaving behind enduring testaments to their engineering prowess. As engineers, we are continually striving to push the boundaries of concrete technology. Advances in materials science have led to the development of high-performance concretes capable of withstanding extreme environments, such as those encountered in offshore drilling platforms or nuclear power plants. Through meticulous experimentation and computational modeling, we gain insights into the microstructural behavior of concrete, enabling us to tailor its properties to meet specific performance requirements. Similarly, physicists play a crucial role in unraveling the mysteries of concrete's mechanical properties. By probing the material at the atomic and molecular levels, physicists elucidate phenomena such as creep, shrinkage, and fracture mechanics, laying the groundwork for predictive models and simulation techniques. Furthermore, the study of concrete's thermal and acoustic properties offers opportunities for interdisciplinary collaboration between engineering and physics, with implications for energy efficiency and urban noise mitigation. Beyond its utilitarian function, concrete serves as a canvas for artistic expression and cultural heritage. Sculptors and architects have long been captivated by concrete's sculptural potential, leveraging its plasticity and permanence to create enduring works of art. The fusion of engineering pragmatism with aesthetic sensibility is exemplified in iconic structures like the Sydney Opera House or the Guggenheim Museum Bilbao, where form and function harmonize in a symphony of concrete and steel. In the realm of sustainable development, concrete holds promise as a cornerstone of green infrastructure. Innovations such as carbon capture and utilization, CCU, technologies offer a pathway to reduce the carbon footprint of concrete production, while alternative binders derived from industrial byproducts promise to minimize waste and conserve natural resources. By embracing circular economy principles and life cycle assessment methodologies, we can chart a course towards a more regenerative built environment. Concrete embodies the convergence of engineering and physics, blending scientific inquiry with artistic expression, tradition with innovation. As stewards of this versatile material, it is incumbent upon us to harness its potential for the betterment of society and the planet. Through interdisciplinary collaboration, technological innovation, and a deep appreciation for its historical legacy, we can continue to build a future where concrete remains not just a material of construction, but a symbol of human ingenuity and resilience. Yet, As we marvel at the wonders wrought by concrete, we must also confront its environmental footprint. The production of cement, a key ingredient in concrete, accounts for a significant portion of global carbon dioxide emissions. As stewards of both science and engineering, it is our duty to mitigate these environmental impacts through innovative solutions and sustainable practices. In the realm of engineering, there exists a vast array of strategies to reduce the environmental impact of concrete production. One approach involves incorporating alternative materials, such as fly ash, slag, or silica fume, as supplementary cementitious materials. These byproducts of industrial processes not only reduce the reliance on traditional cement but also contribute to the reuse of waste materials, thus lessening the burden on landfills and natural resources. Furthermore, advancements in concrete mix design hold promise for enhancing both sustainability and performance. By optimizing the proportions of ingredients and adjusting curing methods, engineers can minimize the carbon intensity of concrete while maximizing its strength, durability, and resilience to environmental factors. This optimization process often involves sophisticated